So let's get into the details. Flutter was released in a version 1.0. They had a really long alpha beta cycle because they didn't want to release initially right away because of breaking changes. It took them to 2018 before they released their version 1.0. NativeScript, on the other hand, released 0.90 back in March of 2015. And since that point, we're already up to version 6.2. So there's been 6 major versions since that point. Each version adds new features that require a breaking change to NativeScript, so that's the reason why they bump it. They're using the semantic versioning system. Most of the time, I should make note, most of the time these breaking changes are pretty minor, and you can pretty much upgrade your app pretty easily to the next version. Flutter has over 4,000 total plugins in its ecosystem, even though it's only been around since 2018. Part of the reason is because Google has put a huge amount of funding into this. A lot of these are Google plugins. NativeScript has 1,000 plugins from the community. The majority of these plugins are from people like you and me. But on the other hand, NativeScript also has access to the entire NPM repo. So all million NPM classes, some of them don't work because they're designed around node-specific things or maybe around a specific browser thing. But a lot of the generic NPM modules will run in NativeScript because NativeScript is JavaScript. Flutter has gained 78,000 stars in its about a year it's been in business as released, where NativeScript's only got 17.8. This is kind of misleading in some ways because Flutter has a huge following from a lot of Google people. So there's a lot of Google people who started this and have been blogging about and have been pushing it. This has been a major focus of Google, at least a subsection of Google, but there is still some infighting in Google about this versus Angular versus other products they have, like the Android, the normal Java, Kotlin stuff. As I just covered, Flutter is owned by Google, and NativeScript is owned by Progress. Flutter supports iOS, Android. That little pink logo is Fuchsia. Google is working on a new operating system. They've had developer previews, really early preview alphas. It's supposed to be for dedicated hardware, but beyond that, there's not a lot of knowledge known about it. And then, of course, HTML5. NativeScript is iOS and Android, and then there is some HTML5 support, which we'll cover later because it's a little bit different than the way Flutter does theirs. So I do want to separate that right now. Flutter is written in Dart. Now, why am I talking about a Dart language here in JavaScript conference? Dart actually transpiles just like TypeScript and CoffeeScript into JavaScript. So for the majority of its life, Dart has actually been used by Google to build like their analytics platform. A lot of it's written in Dart, but it transpiles to JavaScript, and that's what they use. Dart was actually designed, at least everybody believes, and this is a story I've heard from people in Google, was designed to be a replacement language for JavaScript. It was designed to replace JavaScript. It is a modern day language. It has generics, static typing, pretty much anything you would think of C# or the latest C standards or Rust or stuff like that. Dart has that ability. However, as you probably know, the web never stops moving forward. And so they were trying to bootstrap Dart, and they even created a browser that ran Dart natively called Dartium, which you can probably still find links on. The web moved forward. JavaScript moved forward. All of a sudden, JavaScript got new wings, and it started pushing forward. And fortunately, at that point, Google decided that it was a lost cause. And so Dart kind of became non-existent for a while. For most of its life, Dart was very not well known. It was pretty much used exclusively inside Google. Oh, I covered that part. As of a couple days ago when I did the search, Dart is now considered somewhere between the 15th to 25th most popular language, all depending on which website you go to. Just so you guys know, Java, JavaScript, and Python are typically the top 3. in some order like that. So JavaScript's way up there still. Why has Dart got to 15th even though it was relatively well known? It is because of Flutter. Flutter is such a hot language that people are learning Dart because of it. The other thing Dart has going for it over JavaScript is it actually can compile to native code. So the Dart applications you can either compile to JavaScript, which is what their HTML module uses, it compiles it to HTML and JavaScript, or when they build it for Flutter, it actually builds a native application, just like as if you had built it in Swift or Object-C or C++. Flutter is a compiled application. Everything is all built, it's compiled, a sole executable with a minor Java bootstrap, just like NativeScript has a minor bootstrap, and React and all the other ones pretty much have like a bootstrap type thing that's in Java that bootstraps it into the native stuff. For those who are unaware, React Native, Cordova, Ionic, NativeScript, even Java apps, the source code's in there. You can grab the source code out of every one of those languages I just mentioned out of the application. So if you're worried about your application source code, that might be something you guys look into about obfuscation or encryption of your stuff. Because if you give me an Ionic app, I can pull out all your keys within 5 minutes. It's not a big deal. React Native, same thing. NativeScript, same thing. Flutter's compiled, so that is a really big positive for it. Because it's compiled, it is also extremely fast. Flutter applications typically start 2 to 3 times faster than React Native, Cordova, PhoneGap, Ionic, Titanium. Flutter is extremely fast. Flutter also has a really cool feature called Instant Full Application Hot Reloading. And this is one I'm going to show you. So let me switch over to my Flutter app, and let me switch over to the emulator. And I'm going to run this real quick. Click the run button. I should have run this before. Sorry about that. While it's booting it up. I will discuss real quick some of the other things is Flutter tooling is top of the line. I have never seen tooling for a mobile application thing as well built as Flutter's tooling system. They not only do they have really nice introspection in the actual code, but you have this outline which shows you the actual layout of how it's going to be rendered. And you can actually take objects and say, hey, you know what, I really think, let's take this text widget. I really think this needs to be wrapped in a row. And it'll automatically add the code right into your place where that text object was at. And so if you go look at this now, you'll see that there is now a brand new row object in that spot. Its tooling is phenomenal. In addition, it has a performance tab, which allows you to see all sorts of cool nifty things, like how the CPU is working, how the memory usage on this is working. It has the ability to view when you make changes to things, like if I click this plus button, it will actually show you in the tree down here what things were affected by that change. So you can actually see what components got modified by my little change. So when you're running your application, you can say, man, this app's running slow. Why is that? Well, let's see what's getting affected when I make this change. And it will show you the entire tree. And it will also show you inside the code, after a couple turns, after it's profiled a couple times, what lines of code it is. So that's why I say Flutter's development tools are really nice. Now, I'm going to get rid of the performance stuff real quick because we don't need that right now. And I'll show you this hot module reloading stuff. Now, first of all, as like React Native and NativeScript, they have hot module reload, and so you can do things like this, and you can say that, if I can spell, and you'll see that it instantly updates on the screen. It still keeps, the interesting thing is it keeps its state, which is really cool, which both React Native and NativeScript can do in a lot of cases. We'll be able to keep their state, and we'll just change the things. This is where Flutter actually shines. I have, in another window, This code is not compiled into the application. The application I compiled is just this demo application. There's only this one file here in this lib folder. This right here is main Dart. That's the file I'm editing. I have in an unused folder, which is not compiled in with a different extension so that Flutter didn't pick it up because I didn't want it automatically compiled in. This is code for another app. So I'm going to Control C. I'm going to go over here in the main file. All right, take it all and just paste it in there. And then I'm going to go New File. And we're going to call this child.dart. And I'm going to grab the child one that I have here. So here, Control C that one. Paste it in here, and I'm going to save it. In seconds, it has updated the application to a completely different app that was not compiled into it at any point in time. This code that I wrote in here was a demo I wrote a while back, but it basically is the equivalent to a native script app that I'm going to show you in a second. But the difference is I just added one whole new screen and I replaced one whole screen, and the app is fully functional, all in seconds. And if I wanted to, I could hit Control Z and back up, and I would put me back at the old app that I was at a second ago, with its state still applied. That is where Flutter's development system is phenomenal, because you don't normally see this ability to be able to change the application so drastically without it actually having to restart anything. It's just, okay, and took it and was fine. So that is one thing that Flutter has done really, really, really well. Now I'm find my slides back. Okay. We already covered Flutter has some of the best tooling. It really does. I mean, the ability to check your memory usage, the ability to see what lines of code are being fired, what things are causing your application to be slow per frame. It has FPS, frames per second. For every single render cycle, it'll actually give you a chart. So this time it took 2 seconds, this time it took whatever. And say you want to try to keep it on this point. So that way you can performance analyze this thing, because Flutter is designed for performance. Flutter, again, is extremely fast. Part of the reason is Flutter was designed kind of like a game engine. The entire rendering system is running under OpenGL. And now, for those who don't know what OpenGL is, it's what typically your games use to display their graphics. It uses the GPU of your phone to render everything. Now, in one hand, this is a positive because it has full control over everything, and the GPUs are typically very fast on phones, so it can just like do all sorts of things really fast. On the other hand, there's a huge negative with this. Because Flutter uses OpenGL, Flutter does not use any native components at all. So when you have a text view, Flutter had to re-implement that in their own code, which means when iOS 13 came out with dark mode, guess what Flutter doesn't support? Dark mode. If tomorrow Android adds ability to use text-to-speech in a text field, guess what Flutter doesn't support? Because they have to re-implement everything. This also goes into, oops, let's switch back over here real quick. This also has to do with the display. Flutter is, Flutter's ability to do material design is probably the best on the planet. I mean, it is built in, its built-in thing is material design. I don't know if you guys noticed the hero thing where the image automatically zooms in. I don't know, you can see if I click here, you can see the gradient thing appear. If I move this, you might be able to see the yellow ending point. All of material design is built into this. I mean, this is really their material design test bed. What they put on their website is really goes with this. They work hand in hand with that team. However, saying that, the iOS side has a completely different UI, which means you have completely different code. If you want your material design application to run on iOS, you can, but it's not going to act like an iOS app. You're going to get the same effects. When I scroll down, you're going to get the little, I can't think what it's called now, this thing saying you hit the end of the scroll list. When I click the buttons, you're going to get the material design gradient. So you kind of have to have two apps. Even though it can run cross-platform iOS and Android, for you to do this, you either have to have a separate widget tree that sets up the things, or you have to run two apps because the code is incompatible. Now they're working on some fixes for that. They're trying to make some of the components more standard. But when I converted this to iOS app, I actually had to change like 5 of my components through my tree. I mean, it's not very big, but it still was finding the components because it would throw errors because the Cupertino components is what they call it, didn't support the material design. And let me show you, and this is really cool. If I take the Cupertino stuff, which I also have, and I lost my main file. And I drop it in here and I save it. You'll notice that the cheese moved over to the center just like iOS. If I click on these things, you don't get the material design link. You'll notice that when I scroll down, it has the overscroll buffer. That it acts like a native app, but it is all written in Dart and their own custom code. So this is not using any of the native platform stuff because it's all rendering via OpenGL. So there's pros and cons because number one, they can't handle everything so they can be pixel perfect. But the cons is they're not using any native controls, which means you might get some differences in experience. There might be something that doesn't work, like dark mode. Stuff like that. Now, I know they've got a bug open right now to get dark mode working. They'll probably have it working, but at this moment, it doesn't. Switch back. Another positive and negative is Dart uses async to communicate to the native platform. In most cases, like 99% of cases, this is actually a great thing because what happens is very much like Node, where it says, I want to open this file. Here's the callback. When the callback's done or promise is done, you call me back. And Flutter does that, all by default. So anytime you're talking to the native side, it sends this over the wire, its internal communication link to the thing, and then that will send it back when it's done, and then it starts running whatever the promise or callback is at that point, which is awesome. However, there's this little 1% that I do want to caution you about. Because it's async, any Android or iOS libraries that require a synchronous call will not work properly. For example, in one of the applications I've built in the past, I had a keyboard thing that actually looked at the keyboard so that while they're typing, I can intercept keys, mainly the volume keys is what I needed in this particular app. Well, the volume key handler, just like in Android, just like on the web, where you have a on key down event, you can cancel the event at any point. You can say, I processed this key, so don't pass it on. Well, because that's a return out of a synchronous function, there's no way for you to send that value back to Dart and have Dart tell you, yeah, I want you to continue processing, or no, I don't want you to process. You have to let the JavaScript finish, or the Java side finish. And so you have no control on your Dart side of what happened with any synchronous handler. And there are several of them throughout the system. In fact, one of the ones I brought up in the bug base was VR. Google had the Daydream VR system, which they just recently discontinued, but they did. They had a really nice VR API. This VR API had synchronous calls in it that you needed to be able to send something into your app, decide what you're going to do with it, and then pass that information back to the Google VR API. Well, guess what Flutter doesn't support? Google VR, because of the synchronous APIs. That is where the 1% can kill you. You don't run into it that often, but there are APIs that are like this. And that bug has been open for about 3 years on the Flutter database to try to get that resolved. And there still is no solution for it. The last solution that was raised, they decided they didn't like. So I don't know when or if it'll ever get fixed. I did cover this. Flutter uses Dart components. Every one of these screen things you see on the screen is written in Flutter, which is really nice. I mean, it just means you can go edit it without a problem. So just to reinforce that. You have full access to the source code. You can edit, update your components. It's very nice in that regard. Okay, so going over some of the negatives. Flutter has no access to native UI. Now they have, the last time I looked, I should say it's been a couple months since I looked, they were working on bridging ability to create a hole in the OpenGL, in their OpenGL implementation, to call a native component. The last time I looked, it still was very buggy. I don't know what this current status is, but they were working on it because of Google Maps and because of a couple other Google large APIs that they wanted to be able to integrate into Flutter. They needed that ability. Videos was another one that they were working on. I believe they have it working. I don't know how well. But for the most part, the general rule is you don't have access to native components. Native UI components, I should say. If you're talking to like Firebase, because there's no UI, there's no problem with that. As I covered a few minutes ago, there's a separate UI per platform. You have, if you don't mind using Material Design, it's great. It works great on both platforms. If you don't mind using the Cupertino, it works great on both platforms. But your iOS users or Android users are going to go, what in the world happened here? I have a completely different interface. So you kind of have to maintain some places duplicate code, at least for certain widgets. The no sync to the runtimes. I consider that actually a big negative in my opinion, because I have written, like I said, 70 odd NativeScript plugins. I can think of probably 15% of them that I couldn't write in Flutter because of that. Because every single API sometimes has a synchronous API somewhere in it, just because it wants a return value. The last thing, the other thing is because Flutter is all its own UI, there are some really weird bugs in Flutter. I'm going to describe the weirdest one that I'm aware of is that you have this text field. You're typing your email address in. So Nathan at, I start to type my last name, A, and all of a sudden it repeats putting Nathan in front of it and puts my A afterwards. So now it says Nathan at Nathan A. What? You delete that again. Nathan at it does again. There's a bug on Flutter that's been open for 7 months that they're working on. For Samsung phones, it's not a big manufacturer at all, where whenever it gets to a line in, like periods, spaces, at signs, it repeats everything that was in the buffer before it. So if you're trying to put your email in and you put Nathan at, then also you get Nathan at Nathan, Anderson dot, then you get Nathan at Anderson.com. So it's all, instead of being your email address, it's like 3 times your email address. And like I said, it's been open for 7 months for Samsung phones. This, to me, is a showstopper bug. I don't understand their priorities. It's still open. Another one would be their camera API. If you want to write a camera app, do not use Flutter. It has some serious crashing issues. They do have a bug open for it, and they are working on fixing it. They actually are rewriting their entire camera API because they couldn't fix it, I guess, in their current API. But it's one of those things you need to be aware of. They tend to have some really weird bugs because they are taking over control of everything. They're not letting the native UI do anything. And so sometimes these native UI things that the UI assumes certain things are going to be present cause issues. There's also a lot of bugs that have been open for over 3 months. A lot. Now, it is a newer environment. I'll grant you that. It's been only out for a year officially. But it does seem to me like they don't triage things quite the way I would triage them. Part of the issue with some of these bugs being over three months is because their release cycle is really long. It takes them a long time to get from master to a stable. A very long time. So if you can live with these issues, or your application isn't going to deal with text input necessarily, Flutter is awesome. Once they have the text input issue fixed, Flutter would be great for text input. I mean, it has a lot of nice text input ability. It has a lot of things that work really well, and it is extremely fast. I mean, a good example of this is I have an app in NativeScript and an app in Flutter. They're the same app. The client asked me to do one in both things. It reads the contact list out of your phone, and we installed 10,000 contacts into this app, just random names, whatever. On Flutter, it can open on a cheap budget phone in less than 2 seconds, all 10,000 contacts I mean, the whole application starts up and loads all 10,000 contacts in under 3 seconds for the everything. And I'm at the main screen with everything in the list view. NativeScript, on the other hand, that's like 12 seconds. Part of that is because NativeScript, the way I initially wrote the plugin, unfortunately, is my own short-sightedness, is I would go and ask the context database, give me the next contact, give me the next contact. And so it would have to marshal that data over the wire through their marshaling thing for every single contact. And so that slowed it down. Now, if I was to rewrite that app, I would do the same thing Flutter did, where I would do all the contact loading on the native side and then just marshal the whole thing over, which would be then really fast. And so it'd be probably more like 6 seconds to boot up, because NativeScript actually is slower to boot up. But you have the same thing with React Native. If your bridge on there, if you don't do everything on the native side and you're marshaling stuff, the marshal has a significant cost, especially when you're dealing with 10,000 of them, which is the reason why I say Flutter is extremely fast, is that it's smart enough to deal with all that on the client, on the native side. And at least the API side of things. And then the stuff inside is, on the Dart side, is all compiled. So it's an extremely fast platform. And the last thing, I consider widget tree hell. I really dislike the widget tree. I mean, I don't know, let me see if you can see this now. Now I have it open. Let me close this outline. But if you look at this, they have this widget returns a new Cupertino page scaffold, which has this child has a column, which has a new flexible, which child has a Flutter anime list, which then has a new cheese box, and then we come down to cheese box, and the cheese box has a new size transition, which has a curved animation, and it's just this long list of children. It's not very flat. It's very much this big tree. It reminds me very much of our callback hell that we had in Node for the longest time, where you'd have this callback after callback, and you'd be down 20 levels deep, and you're like, which callback am I on now? I feel the same way when I'm writing Flutter code. I feel like the tooling helps you a lot. I mean, you'll notice that right after each of the closing things, it tells you what the close piece is. So it tries to help you understand what level you're at, but it still can get very confusing. I wish they would do something about that. I don't know that they are. They've done some things to clean things up, because every one of these components you used to have to put new in front of. So some of this code still has new in front of it because it was written a long time ago. Nowadays you can get rid of the new, just get rid of extra keywords. But still, you end up with an interesting tree all the way down. Okay, so let's get to NativeScript. NativeScript is a TypeScript-based framework. It's all written in TypeScript code. All the core modules, the Angular plugins, a ton of the plugins are all written in TypeScript, and then it's compiled to JavaScript. Right now it's compiled to ES5. They're working on ES6 to make it go to ES6. That actually should be soon, I believe. But that really doesn't matter. It's just the whole framework's TypeScript, which means that you get in VS Code really good feature completion. So you know exactly what procedures to call, easy ability for it to finish. And it also has TypeScript definitions for the Android and iOS native libraries. So when you're typing in java.util, it'll pop up date as the next possibility, because it knows that that is one of the modules under the Java util namespace, which makes native coding very simple while you're doing it in JavaScript. NativeScript uses V8 engine on Android. They are working on the iOS version. They actually have a beta or alpha. It's probably beta now for iOS. They've been using JavaScript core for the longest time, but they're going to a single engine V8 just because V8 offers a huge amount of benefits. For those who are unfamiliar with V8, V8 is what runs Chrome, runs Node. It's the underlying JavaScript engine of those two platforms, or the new Internet Explorer, Brave, pretty much most major browsers. The V8 engine has some of the best ES6, ES5, ES 2016, and ES Next support of any engine. The Chrome team really leads the way a lot of times in some of these things. Firefox does in some areas, but most of the time Chrome's V8 team keeps in sync. So if the Firefox team adds a new feature, Chrome is pretty close to having it afterwards, or I should say the V8 team is pretty close to having it afterwards. So you have almost the entire ES6 fully supported. I believe the only thing that's not supported in ES6 is tel-call recursion, which most of you probably don't know, and I don't even know what it is. It actually has to do with optimization. But ES 2016, they've already got things like big decimal, so you can use big numbers now. They've already got underscore you can use as, instead of to delineate numbers. So if you have this big number like 2,000,015, you can put 015 underscore 000 underscore 2. And so then when you're looking at it easily on the screen, you can say, oh, this is 2,000,015. So it already has that type of support. It also has excellent memory usage. It also has some of the best optimizations. Now, Firefox has a really nice engine too, but I have not seen anybody actually use the Firefox engine for anything but Firefox. V8 engine is pretty standard because of Node's usage of it, and because it offers all these things. And the NativeScript team actually keeps up to date with the latest version. So once Chrome releases their release version of the browser using whatever version of the V8, typically the next release or the following release, within 1 or 2 releases, you'll get the next version of the V8 engine in NativeScript. So you get those features pretty close to when they're getting announced on the blogs, which is really cool because you can then actually test out and use these features. NativeScript uses Webpack for its building of the JavaScript site, which means you have access to all the Webpack plugins. You have access to the Webpack rewriting, Webpack to set environmental variables, or can read your environmental variables to make changes to your source when it's deploying it to production or development. This adds a lot of additional ability for the NativeScript app. In addition, this Webpack is also used to do the HMR. So if you're used to using Webpack in your web development, it's the same process. It'll pick up your changes and push them to the application. And it has the same limitations as your website would. If you're doing something that's like a major change, Webpack will probably restart the service. I mentioned this earlier, you have access to the NPM JavaScript ecosystem. There is a lot of modules in NPM that don't work because they're custom for Node, but there is a lot of modules that do work. A lot of modules that don't work are pretty simple if you know JavaScript well enough to fix to get working. Because as long as the module is pure JavaScript, it should work. Now this is what I consider NativeScript's defining trait. It has full access from JavaScript to the native device's runtimes. What I mean by that is this example. This is JavaScript code. Constant date, using ES6. I'm asking for the Android namespace. If you go look up your Java documentation, the Android namespace, I'm looking for the text subobject, format subobject, date format subobject, .format command. I'm calling for my JavaScript into that format command with that JavaScript string, and then I'm saying I'm creating a new Java util date that I'm passing in. Now, this is kind of contrived because in JavaScript you just do date. But I want to show that you could literally call anything in the Java runtime. And this bottom one where it says new Java util date, I could have actually passed a JavaScript date object. The NativeScript runtime is smart enough to take, when it goes over the bridge to marshal into the native side, it looks at what the type is and goes, oh, this is a JavaScript string, but it actually needs to be a Java string. So we're going to convert it to a Java string and pass it in as Java string. Oh, this needs to be a Java date. So we're going to take the NativeScript JavaScript date and convert it into a Java date. And so what I get back here is on this date object is actually a Java object. It's probably a Java string if I remember right. But I can do .toString, and NativeScript will go, oh, you're wanting to convert the Java string into a NativeScript string, or into, I should say, a JavaScript string. Java string into Java string. Okay. Tongue twister there. You can do this with any API on the Java thing, even third-party APIs. Anything that has a Java ability for you to talk to from a Java program, you can talk to from NativeScript. Kotlin support is decent. We're still working on adding more features to Kotlin. There's still some things that Kotlin does that NativeScript still has problems understanding the metadata, and they're working on through those things, but a lot of Kotlin stuff now works also. So this is the Android side. Unfortunately, Object-C is a lot more complicated, a lot more verbose. This is the exact same code for iOS. I create a constant date formatter. I'm saying, I want the new NS date formatter. I'm allocating initting it, or I can do .new. Either one works. But a lot of people are familiar with the alloc init thing, so I just show that. Then I'm saying date formatter, set my time zone. I say give me whatever the device's default time zone is. Again, this is JavaScript code that's calling into the runtime. The runtime knows that NS time zone is a runtime value. It knows default time zone is a runtime value, so it doesn't have to do any conversion. It just passes it right on in when it calls that function. The next line, date formatter, set date format. I'm giving it the same string, year, month, day, hour, minute, seconds. And then I'm saying date format string from date, and I pass in a default date. All this was Object-C code that I took a couple minutes last night, or not a night, converted it to JavaScript. On the iOS side, you have full access to the Object-C runtime, the same way. Anything that you can find in the documentation for Apple or whatever, you can call in NativeScript. There's a couple small exceptions, but for the most part, Java and Object-C is fully supported from NativeScript, and that goes for third-party components. So if you see this awesome graphical charting library, like SideCharts, that has a Java version and an iOS version, you can take those modules, put them in your NativeScript app, and call them just like their docs tell you to, but from JavaScript. And this is where NativeScript, in my opinion, is the best of the platforms, just because of this ability here, because you can do everything from inside of JavaScript. Now, this Android text format, date format, the top one and the bottom one, the typings that you can get that come with NativeScript will actually give you that information. You can start typing NS date format, and it'll fill out and format it. Hit dot, it can bring up the code completion that alloc is on there. That stuff is built into NativeScript, and it has the typings available for it, so that this kind of code is very easy to do. Now, normally in the NativeScript community, we actually create a plugin for something like this. We have an iOS file and an Android file, so that way I would say getDate is my function, and the getDate would return me one of these two things just based on which platform. So that way my application is cross-platform and doesn't have to have any iOS code into it when I'm building the Android version, and it doesn't have to have any Android code in when I'm doing the iOS version. And the entire NativeScript library or runtime is built this way. It has the equivalent versions of, for like a label, for printing text on the screen. You just say, I want a label. And I'm passing in this text to put in the label, I want this background color. Underneath the scenes, the core team has written already all the calls into Object-C to make it happen identically on Object-C, and all the calls for Java. So all you worry about is the label and the properties on the label, but you don't have to worry about the native side stuff. But if you want to worry about the native side stuff, you can get access to that object, and you can call any function that they didn't implement off the native stuff. So if you wanted to worry about kerning on the label, kerning is not one of those things that's like built into the runtime. But you could say, give me the label, .native, .kerning, whatever the command is to set the kerning on the label. And I've done that. There have been a couple times where I've had a client that says, I need this. I absolutely need this. Okay, if Android, do this. If iOS, do this. Okay, so we basically covered it. Full access to the native runtimes on iOS and Android. And that includes third-party. I just want to stress that. Third-party libraries. You pretty much have full access to. Swift and Kotlin, there's some issues with. Most of the time it works, and there's some stuff in the brand new version of NativeScript that actually fixes a lot of the Swift 5 issues, but there still can be some issues. Day zero support. What do I mean by that? Well, because you have full access to the runtimes, you're never limited by the NativeScript team. When iOS 13 came out, NativeScript ran on it fine. There were some issues, but I could go in there and fix them very easily because you have full access to it. So when my client told me that dark mode wasn't working, I went and Googled what dark mode did to figure out what they were doing, what iOS was doing, and figure out, oh, okay, so I just need to call this API when I start up my application. Boom, I'm done. Now, if it's on iOS 13, it does this call, and everybody's happy. I did cover this a bit. Virtually all third-party components. I have very rarely run into a component that I couldn't get working in it. There are some, like I said, there are some exceptions, but for the most part, third-party components work out of the box. I mean, you have to code them up, obviously, whatever the APIs that they use. But that goes for UI components or non-UI components. Again, you have full access Object-C, Java. Those two are supported like pretty much like 99% of coverage on those two. I mean, there's very few things that don't work properly with those two things. There's like unions don't work properly, and a couple things like that that are like you're probably never going to run into anyway. Although there's ways around it. I should mention that. Swift and Kotlin are really, they're coming up. They're a lot of Swift 2, Swift 3, Swift 4 components work great. Swift 5 has some metadata issues, which they're fixed a lot of them, like I said, this last version. Kotlin also has some features in it that the metadata isn't always gathered properly, and so it's unable to use some of that stuff. Again, there's ways around it. I touched this a little bit, but the NativeScript app, literally when you build it, you're using the exact same code base. The iOS version performs like an iOS version because it's calling the iOS native call functions. So you get the same scroll thing, you get the same label in the center, everything that you're used to on an Android UI, you get on the, iOS UI, because we're talking about iOS. You would get on an iOS device when you build it for an iOS device. Same thing on Android. When you build it for the Android, you would get the Android versions of those things. Almost every major component that you would need in an application has already been wrapped. There's obviously exceptions to that. You know, you might have some weird charting requirement, although there is a chart component, but if you might have some weird requirement where you do have to wrap a third-party component, or you might have to call some weird database call like Amazon S3, not S3, Amazon DynamoDB. Stuff like that, you might have to add code to do that. But you can. This is a smaller feature to some extent. Because NativeScript has the ability to, because NativeScript running in JavaScript, the same thing applies with React Native and Cordova. You can technically update it outside of the store. Now, Apple has certain rules about that, but Microsoft's Code Push, and I don't remember what their new name is for that, service allows you to do that with React Native and a couple other things. There's a version of that that's in beta right now for NativeScript, so you can do the exact same thing. If you want to do certain out-of-band updates, you can easily do that. Flutter cannot do that because Flutter is all compiled. But most of the time, you can do out-of-band updates with NativeScript. And Apple's rules really are, don't change the interface. They don't want you to ship a sports app and turn it into a porn app. That would make them very upset with you. Now, I did not plan for this because we had ice cream earlier, but I thought that was really great. So I have two flavors here. So who likes chocolate here? Who likes vanilla? You like both. Well, one of the interesting things about NativeScript is the NativeScript flavors. NativeScript actually supports a huge number of flavors. There you go. I think you want that, Sebastian, right?
Oh, yeah.
First of all, there's NativeScript Core. This was what was originally released with NativeScript back in March of 2015. It survived by itself for about 2 years. It was its own thing, and this is actually my platform of choice. NativeScript Core, it's the base system. Then, sometime around I think late 2016, maybe 2017, they added NativeScript Angular, so you could take your Angular code, run it as a NativeScript app. And the interesting thing is that the build system takes your NativeScript components, your Angular version of the code components, and converts it into native components again. So you're still getting the same thing as you would have in NativeScript Core. But you can use Angular code. This is where the web can work with you, because you can actually create the same application on web in NativeScript. The only difference is your screen, because you might, for your web, you might use a div, where in NativeScript you would use a stack layout. So you would actually have a different HTML file for the actual layout, but the actual underlying code can be anywhere from 90 to 100, almost 100% the same. The only difference is, like, say you want a picture uploader. So NativeScript Angular, you might have to have your own screen that takes a snapshot, or on your website you would redirect to a page that says upload your picture. But the underlying logic of after the picture gets to the server, or displays or whatever, could be identical. You're just grabbing the picture from some piece. NativeScript Angular is very well supported and has two different platforms that allow you cross-platform stuff. One of them is the built-in way, which allows you to have a separate config file, which allows you to switch and you can have different files. And the other one, which I'll cover at the very bottom, is called XSplat, and I'll cover that in a second. And then recently, well, not so recently, I think it's been out for a year and a half, NativeScript Vue. If you happen to like Vue, you can do the same thing in Vue. You can create your components in Vue. You can do everything you want. Again, you have the same similar limitations. You have different components because you have divs on web and you have stack layouts on here. So your biggest difference, again, is just the layout. Normally the logic is pretty much, business logic is pretty much cross-platform across all your things. If you think that's nice, React. We have someone that's working on React NativeScript. It actually takes React screens and you can do the exact same thing. Anybody want Svelte? We got Svelte native, Svelte native. Same identical thing if you happen to prefer that way of doing your framework. This showed up on my radar 2 days ago. Glimmer, Ember. You can do it now, Glimmer. I don't know of any other platform where you can choose whichever web platform you feel the most comfortable with and create a NativeScript app with it. It's incredible. And the last one is InStudio actually has an XPlat platform. And what it is, it's Angular based also. But it actually allows you to create an application that works on the web, works in Ionic. You can create an Ionic app with your Angular code base. It create an Electron application or the NativeScript mobile application, all from basically one code base. Again, you still have the same limitations where you're a label versus a div or whatever, the screen side of things. But your actual logic, and every one of these can be identical. That's pretty unique, actually, in any of the mobile frameworks. Some of them have one, some of them have, I know React Native has an Angular thing. The last time I looked at the support, it wasn't that great. The Angular support in here is top line. It typically fairly closely follows the latest version of Angular within a couple releases. Typically, like 2 releases, you normally are at least the latest again, especially when they make major breaking changes. The Angular support in NativeScript is top notch. Vue is pretty close to top notch. They're sometimes behind, sometimes they're right on. So it's hard to always say. But I do know of several people who've made NativeScript Vue apps that are both web and mobile. React NativeScript, that's more early beta. There's still issues with it. Svelte native is beta. Glimmer is probably alpha. Like I said, I just showed up 2 days ago. But I'm like, ooh, cool. Now some of the NativeScript's negatives. It is a smaller community. Flutter has a huge community. NativeScript's community is a lot smaller. That's partially why you can see the difference in the stars. And the GitHub stars in the beginning, because their community is a lot larger. NativeScript also has a slower startup time. It is running the V8 engine. It has to bootstrap the V8 engine when it starts up. That is a hit on the CPU. It actually literally has to start up before it can run the code. It has gotten drastically better over the years, but you still have that hit. So NativeScript apps, React Native, Cordova, PhoneGap, they're all going to have a similar runtime initial hit. Now React is working on that with their Hermes engine on Android, but you still have some hit. On the Flutter side, you really don't have Google in their corner, which is a huge huge company. So it's not. Progress is also a huge company. There is no other major companies in this industry thing. Or React Native, you've got Microsoft, Facebook, I can't think of it. There's like several big name companies that are all in the React Native community. So there is pros for React Native. And I didn't cover too much React Native just because of the time constraints. I would have gotten into that. But there is no other players but Progress really in this industry, in this major players, I should say. However, they're very committed to NativeScript, just so you guys know. React Native, NativeScript, Cordova, Titanium, Ionic, source code's in the app. I mentioned that at the beginning. Literally, your code has to be compiled and typically web-packed and compressed and uglified into, but it's still all there. So if you have keys or secret URLs, take a look at that. It's a security possibility problem. Flutter, because it's compiled, it's not as big a thing, but again, if you hard code your URLs, I can pull that out of Flutter app too. So I mean, you have to think about these things. The tooling compared to Flutter is not nearly as nice. The tooling is nice, but when you compared to Flutter's tooling is incredible. I mean, I'm so impressed with everything it does. In NativeScript, there's a lot of times you have to, I'm doing memory things, so let's go in Xcode, open up the application, see if I can track down this thing. If I'm trying to find a memory leak, it can be very difficult sometimes in NativeScript just because you have that bridge between native and JavaScript. And so you don't know, it can be hard to find if the memory is being leaked on the native side or the memory is being leaked on the JavaScript side, or if the JavaScript option is holding it. And so there's tools that they're just not as good as Flutter's. Community PRs and NativeScript, I have to admit, that's one of my sore points with the team. They can sit for months. They are busy, and that is the excuse. They are fixing things, but a lot of times the PRs, I think, not so much get forgotten, but maybe along those lines where they see this PR, they go, oh, cool, but because someone on the team didn't get assigned to do anything with the PR, it gets forgotten about because now it's not a new issue, so which means it's not in their inbox anymore. And just like bug reports to some of my applications, they can get filtered right out. That is a problem, and I know they're talking about ways of solving that. They are aware that's a problem, but that's something that Flutter does do right. Flutter's community PRs get merged very quickly. The biggest issue is that you may not see it for 3 months because of the way they do their releases. Where NativeScript, once the PR is released, it'll be in the next major release typically, which is somewhere between 4 to 6 weeks normally. Normally 6, I should say. There is Kotlin Swift metadata issues. Like I mentioned before, I just want to be upfront about that. I have spent days dealing with Swift metadata issues. It's not fun, but there's ways around it. Object-C in Java, though, I can't think of the last time I've run into any issues with it. There is no canvas in NativeScript, and OpenGL support on Android is non-existent. You can't, I shouldn't say can't, I should say literally impossible to do OpenGL support in NativeScript. It is not something you want to try. The biggest issue is NativeScript, I should say on the Android side. On iOS, it isn't this issue. On the Android side, OpenGL actually runs in its own thread. NativeScript, because of its design, wants to always be running on the parent thread, the master thread, the UI thread. OpenGL will switch you to a different thread, which then gives NativeScript some confusion about where it's running from. And then, boom. So, OpenGL, if you're going to do a game, NativeScript probably isn't what you want to do it in. Typically, if you're going to do a game, I would use Unreal or the other Unity. They're a much better platform for actual games. However, on the flip side, VR support, funny enough, I've embedded VR support into NativeScript, which does use OpenGL, but it takes control of the device. So if you're taking control of the device, where you're not calling it from JavaScript necessarily, and you're funneling images or whatever, but you're basically saying, hey, VR, here's my images, and you run with it. That works great. I've embedded Unity in NativeScript. Actually, Unity. Unity game running in NativeScript. I've embedded OpenGL, a VR in NativeScript. You can do those things as long as it takes full control of the OpenGL side of things. But you can't really do pure OpenGL in NativeScript. So that is a definite limitation. Okay, so NativeScript or Flutter. NativeScript, if you want to reuse your web skills, it's a no-brainer. Okay, sorry. Flutter, faster development tooling. NativeScript, because it's all JavaScript, you have full access source. You can easily work around issues. You can also monkey patch. I've done that with many plugins where I've monkey patched into their runtimes and it solves my issues. Solid multi-platform support, solid extensibility, iOS and Android native out of the box. On the Flutter side, if you want very fast applications, it really is the fastest mobile runtime out there. If you don't need any third-party support, as long as the plugins they have already existing work with it, as long as you don't need any UI components, Flutter's safe. And if you can live with bugs being unfixed for months. If you don't need access to a camera, or if you want solid material design, because NativeScript material design is so-so. You can do it, you can theme it, you have good access to theming because it's fully CSS for those who are unaware. That's why I say awesome reusability for web skills. Java, HTML, CSS, if you know those things, you can build yourself a NativeScript app. Any questions?
And we have the React Native comparison on that.
I'm sorry, what?
We have the React Native comparison as well there.
I don't think they're going to let me do that, but I can talk to you afterwards. I just picked those two because I figured most people were not familiar with those two, but people are familiar with React Native more often than not.
Are there idiosyncrasies in how Flutter implements these brand new components? Like, will an iOS app in Flutter feel exactly like an iOS app created in NativeScript or in Swift?
For the most part, yes, but there are idiosyncrasies. Because they can't implement everything properly, there are some things where they haven't implemented things that you would see in a native app. So there are some idiosyncrasies. It's not as bad as PhoneGap and the web-based, based components, but there are some.
I'm afraid I'll have to cut you off because we're running out of time.
Sorry.
Yeah, 45 minutes, it took an hour, so he included Q&A in all of his answers. But like Nathaneal is gonna be around, so please grab him and feel free. And we're gonna take a 5 minutes break now.